Welcome to this video in the electrochemistry topic, looking at the limitations of cell potential predictions of reaction feasibility. What we really want to try and understand in this video is the difference between a feasible reaction and one that actually takes place in practice. And then we want to know the factors that are actually going to affect whether a reaction takes place in practice and when our predictions that it will are likely to be subject to errors. Okay, so let's just start off. This is just something for you to do, so pause the video and see if you can write a symbol equation, an ionic equation, and then the half equations for when lead reacts with dilute nitric acid to form a lead-2 salt. Okay, here are the relevant equations, symbol, ionic and half equations. Pause the video and check whether your answers were correct. Okay, so here are the videos that are actually, the equations that are actually involved. Now what we want to try and do with the tools that we've been learning throughout this topic is actually predict whether this reaction is indeed feasible. And so in order to do that, I've just taken an extract of the electrochemical series with some relevant reactions in here, and the ones that we're really interested in are these ones. So in this particular reaction, if we look back at the half equations that are happening, we've got H plus 2 electrons forming H2, and that is actually the forward reaction in this particular case. So we want the forward reaction, which is reduction. So H plus is going to get reduced. And in the opposite sense, lead is going to get oxidized. So it's the reverse reaction that we're interested in. So we can calculate E cell for this reaction. Again, something that you could pause the video and try. So we're going to do E standard cell. Because it's a reaction, we're going to do E of the reduced species minus E standard of the oxidized species. The reduced species you said is hydrogen, that's 0.00, subtract minus 0.13, and that gives us plus 0.13 volts. So from that we would say that this reaction is a feasible reaction under standard conditions. So what we can do now is actually try that reaction in practice, and what we're going to do is actually try it in parallel with a whole load of other metals, so magnesium, zinc, iron and copper. And what we can see from the electrochemical series here is actually that any negative number here will give a positive E cell, and so actually all these ones here, so anything that's above hydrogen in the electrochemical series with a more negative standard electropotential, we're going to say feasible. And these are the metals that are above hydrogen in the reactivity series. That's a bit of a vague term, but to make a connection with what you should have done in previous chemistry courses. So this is above hydrogen, whereas we would say that anything which is positive is going to give us a negative E cell, so this is going to be unfeasible. So our prediction then, if we take these 5 metals, is that we should expect to see hydrogen gas being produced by all 4 of these, but nothing coming off the copper. So let's see whether that is actually the case. So here's a picture of what's happened. We can see here the copper, as we might have expected. We've got no observed reaction here, so observed reaction, and that one's not supposed to happen. Well, that's okay, because we didn't think it was going to happen. But the lead, which we said was feasible, doesn't really seem to be reacting either, and neither does iron. Zinc, we can see the bubbles on the surface, the hydrogen gas, so that's reacting. Magnesium is reacting very vigorously. Okay, so the observed actual reaction, even though we said that all these ones here are feasible, not all of them are actually occurring in practice. There's a limitation to our prediction, and the limitation is a limitation of reaction rate. So they're not observed in practice due to a slow rate. And a slow rate means a high activation energy. And essentially that's just the really important point to notice, is that E cell values are telling us about whether reactions can happen from what we call a thermodynamic perspective, an energetic perspective. Do we have to actually continuously add energy into this reaction to make it happen? If not, then it's a feasible reaction. However, that doesn't tell us anything to do with the rate or the kinetics of the reaction. We see a big divide here in chemistry between thermodynamics and kinetics. So, however, if we look carefully at these numbers, what we can see here is that the reactions which have got the biggest E cell value, the most positive, are actually happening. So there does seem that there is some kind of relationship between the size of the E cell and the reaction. And so what this has led to people saying is that if you have E cell bigger than about 0.4 volts, then that is basically saying that the reaction takes place in practice. It's not an exact science, but it's a rule of thumb that can be helpful in different situations. So if you happen to be in a position where you've calculated or you think a particular reaction should happen, calculate the E cell. If it is less than 0.4 volts, then it may not be happening due to a slow rate of reaction. So to summarize this, feasible reactions are those with E cell bigger than 0. That's the definition of a feasible reaction. A feasible reaction, however, may not occur in practice due to two factors: either a slow rate of reaction, which is what we've really discussed here, or non-standard conditions. So if E cell is not equal to E standard cell, then you could end up with a reaction not being feasible. So essentially E cell is less than 0, even though E standard cell was bigger than 0. And that could be non-standard temperature, or it could be non-standard concentrations, anything that will affect the position of equilibrium. Equilibrium positions can potentially have an effect. Now, commonly, reactions where you see an E cell from between 0 and 0.4 volts are observed to occur too slowly in practice. And therefore, E cell greater than 0.4 volts is sometimes used as a condition for a feasible reaction to occur in practice. It's not exact, but it's just an empirical rule of thumb that's been developed.